Welcome to this introduction to photolithography. In this video, I will explain the main theory and steps to fabricate microfluidic chips using photolithography. Photolithography is a process triggered by light where light-sensitive material, normally called photoresist, is affected by this light, changing its mechanical properties. Like this, we can either have positive photoresists that become more soluble when light shines on them, or negative photoresists, the ones that become solid when the light shines on them. By using these kind of materials, photosensitive materials, and any kind of mask that creates patterns blocking light or allowing to pass light, we can transfer these patterns to a certain surface. Here in our microfab facility, we can fabricate these microfluidic chips, all the process from the beginning, from the generation of the mask to the final device used in microfluidics. Let's see how to fabricate a mask. For this process, we use a laser writer machine. This is a photolithography machine that uses a laser, so a very small spot with a certain wavelength. So what we do is we think about the design, we create it, for instance, in AutoCAD, we transfer it to the machine, and then the laser will be writing that pattern on the surface of our mask. This is how one of the masks look like before the lithography with the laser writer. This is a glass with a layer of metal, and on top a layer of photoresist, this light-sensitive material. In particular, this is a positive resist. We introduce our mask here, we write our design pattern on it, and then after a process of development, similar to the one that is done in photography, we'll reveal that pattern and we etch away the exposed areas of metal, getting things as this. This is a mask fabricated here with different patterns, microfluidic patterns. And as you see, it creates parts where light is blocked and parts where the light is passing. We use this machine to create these masks because they require high precision, and this machine can go down to 1 micron. However, it takes a lot of time, so we use it only for the fabrication of masks. And like this, with a single mask, we can replicate this design in different substrates by the next technique that I will explain later, and that is much faster. Let's see the next step. Once we have the photo mask, we will transfer this pattern to a certain substrate. Then we take our final substrate and we need to coat it with another layer of photoresist. For that, we use this machine. This is a spin coater that allows us to deposit a uniform layer of a certain fixed thickness on this substrate. Now with the mask and the substrate coated with the photosensitive material, we go to one of these machines. These are mask aligners. This, for example, employs a lamp, a mercury lamp, that shines in a broad band in ultraviolet. And this one is another mask aligner that uses an LED, so a fixed wavelength. We put these things together, as I will show you. We take our coated substrate, fix it here, and we add the photo mask. Put them together and then shine. Then we affect these certain parts of the substrate with the light, and we can, as before, develop and generate a pattern. Getting our final substrate pattern in photoresist. Now we have this, which is an exact replica of the mask that we had before. This is what we call a master, and it's from where we get our microfluidic chips. The chips that we fabricate here are made of PDMS, which is a polymer, transparent, flexible, and biocompatible. What we do is take these masters, we pour the PDMS, and after a process of curing, it becomes hard, solid. And we peel it off from these masters, getting replicas from the masters on this polymer. Before pouring the PDMS, we treat these masters with a silent treatment, which is anti-adhesive, which is beneficial to peel easily these replicas from the masters. This is an example of one of these replicas in PDMS of one of those designs. This is a replica in PDMS closed on a glass, and this is what is typical microfluidic chip. Our researchers use this in their experiments, and like this is ready to use. So with this, we finish this introduction to how to fabricate microfluidic chips by photolithography. Thank you very much.